at least. Oh, sorry. Okay. Okay, do you want to stay in here? Or can you stay for this period?
I have my reading growth and development
Okay.
right now.
We're have a quiz tomorrow, but it's not basically anything new, but it is advanced fact functions and composites and numbers, okay?
Well,
That's fine.
I think
You can do a question after.
Yeah. No, use that. Where is the other one?
You're welcome, sweetie. I do. In the purple folder, like in the second from the bottom row, it's on the back of the worksheet from yesterday. So you might see the front of it. See how they're Monday, Tuesday, Wednesday? Yeah. And so here's some of that. Anybody not have a worksheet from yesterday? Okay, get it out. You need colored pencils. You need your notes out. You might want your green sheet out. Okay, if you don't have your batteries or your money by tomorrow, and if you have a rechargeable calculator, I need to know it, I'll mark it off. But by tomorrow, the people that haven't done it, have paid it up, and levied up with me, I'm moving up to the front of the room for the rest of the semester. It's the only leverage I have on you guys. I'm not going to call your mom and say, hey, send the money. I'm not going to do that. You either are responsible or you can sit up front with me. So pick your poison. Okay. You're Haley? Yes. Gotcha. You already up front. You didn't have anything to lose. Yes, sir. Speak really loud. Yes, I don't need that if you're driving. Well, you already did it, that's okay. Last name? Okay, there's two people here. Anybody else? There's enough for two. You want to give it to anybody else? Anybody else? Okay, anybody else?
I have a rechargeable calculator.
Okay, hold on. Alexia. Okay, yesterday we did the front side of this worksheet. We talked about functions. We talked about increasing, decreasing. At that moment where it goes from increasing to decreasing or decreasing to increasing, there was a moment, an instant where the slope went to zero. We talked about the roots, the solutions, the x-intercepts, the zeros. Now, I honestly think you should grab your green sheet and somewhere in the corner, I think you should write those 4 words down. Roots, solutions. Just put them all together and put a little cloud around them or something. Because, like I said, you're going to see those on an ACT test or something, and they're going to mean the same thing, but they're going to use it differently. And I need you to know they're asking you for the same thing. Roots, solutions, x-intercepts, and zeros. I don't care which order you put them in. And I don't know if that has to do on. Do zeros have an E? Do you think I know that as a math teacher? No? Okay. Well, I made it messy so we can't tell the road. So you don't know if I spelled it wrong or not. But you need to remember that when you see one of those, it means all of them. So on an SAT test, like you're taking it this weekend, or ACT, whichever one it is this weekend, if they ask you on question 5, what's the root to the problem, and on question 15, they say, what's the solution? I don't want you to get all kind of wonky in your head and go, I don't know. Yeah, you do. They're asking you for where it crosses the x-axis. It's just different words for it. Okay, let's look at this function now. Again, I'm going to use some colors because I'm going to write on top of myself over and over and over again. This is a little bit more advanced. I'm going to write a note to myself up here, and if you're on that worksheet, it's on the back. If you have yesterday's worksheet, it is the back of yesterday's worksheet. Let's make a note to ourselves up here on the top left hand of this worksheet about interval notation. I need you to remember, interval notation always goes littlest to biggest. No choice. Interval notation can be one set of numbers, it can be 10 sets of numbers, it doesn't matter. If I want to say that, I could say 5 is less than or equal to x, which is less than or equal to 20. That's using less than or greater than signs. If I wanted to write that in interval notation, you see the equal part of that sign. That's an equal sign. So I want to include 5 and 20. So I'm going to do 5 to 20. And since I'm including them, I'm going to use the square brackets. That's interval notation. Now, if I had done 5 is less than x, which is less than 20, which means x can be anything between 5 and 20, but not including, then I would use those parentheses between 5 and 20. I can use 2 parentheses, I can use 2 brackets, I can use one of each, but I need you to remember that infinity always has a parentheses. So if I just want to say, I'll write it over here, x is greater than 2, then we'll make it greater than or equal to 2. Then 2 is the littlest it can be anything bigger. And if you were to do this on a number line, you could see this kind of as an arrow going that way, but anyway, it's going to go to infinity. Okay, I want to include 2, so I'm going to put a brackety thing on him. But infinity, we never know that number, because no matter what number you give me, I can give you one number bigger or part of a number bigger. So he's going to have a parentheses always. Okay, I just wanted to kind of go over that again with you. I know you've had that in Algebra 2. But that's the kind of little bits of information that if you're not sure of, that's the kind of little thing you might run up on your green sheet. That, the root, solutions, x-intercept, zeros are absolutely mandatory as far as I'm concerned. I have to get those in your head, and when you hear one of those words, the other 3 just come spilling out of your mouth. You need to know they are totally interchangeable. Are we good so far? Okay, now I'm going to move this up just because I've kind of written on it. This is a little bit of an advanced function. Before we start talking about it, let's talk about what we know. First of all, is it infinite or finite?
Finite.
Okay, that's an easy one, right? Because there's no arrows on the end. So basically, the only information you can give me is where between x equals negative 10 and x equals positive 10. If x is less than negative 10 or greater than positive 10, you don't know. It does not exist as far as you're concerned. Okay, how many times does this thing cross the x-axis?
4.
Okay. I'm going to give you another hint. Yes, you're sort of right. And you're sort of right. You're not very right. Okay, let me back up a minute. When you had a quadratic, how many curves did you see in a quadratic? 1. Okay, so x squared had 1 curve, 1 change of direction. X to the third, like it's like a cubic, looks like this, has 2 changes of direction, right? Let's look at this one. It changes direction once, twice, 3, 4, 5 times. 5 changes of directions. That means this is x to the 6th. Now, whoever said x to the 4th, you were right. There are 4 distinct roots. But, hold on, I'm sorry, I forgot to turn my phone off. People are trying to evacuate horses now, and it's just too late. Okay. X to the 6th. Okay, we had 1 root here, we crossed here, but then we had these 2 roots also. But in Algebra 2, you learn that when it crosses, that's a single root. But when it bounces or touches or whatever word you learn, that's a double root. So there's 1 root, 2 roots, 3, 4, 5, 6. There are 6 roots. Okay? The question could be tricky. It could say how many distinct roots are there? There's only 4. But how many roots to this picture we have? There are 6. If I asked you to list them, the roots, the solutions, the x-intercepts, the zeros, you would tell me negative 10, negative 5, 0, and 5. Now, if you were writing this, and we are going to get into writing higher order polynomials, you need to know which ones are double roots. Now, I don't care how you do it. You can choose to do it differently than me, that's for sure. but I'm going to have a little way to mark it. I'm going to say, okay, negative 10 was a single root. Negative 5 was a single root because it crossed. But in the origin, at 0, it bounced. So I'm going to put 2 little lines under there to show me that I need to use it twice. It is a double root. On positive 5, it is a double root. If I were to get a fake polynomial or factored polynomial of this, and it's not true because I don't know all the real particulars, I could say x plus 10, x plus 5, I'm running out of room, x minus 0, but I'm going to square it because it's a double root. I can write it twice, but I'm too lazy, and then x minus 5 squared. Now, x minus 0, that's still x, right? Okay, so the better way, the way you're going to see it written when I give it to you, x minus 0 squared is going to come out to be x squared times x plus 10, x plus 5, x minus 5 squared. So x squared, when you see just an x or an x squared or x to the third, it has to go through the origin. That means 0 is a root. Now you remember all that, right? Did you learn bounce or touch? What word did you learn in Algebra 2? Did you get to that in Algebra 2? Okay, again, please let me know, because with last year was so crazy. And this year's it's just continuing to be crazy. Okay, so the rule is if it crosses, it's an odd root. 1, 3, 7, 17 times, whatever. But if it comes back to the x-axis and bounces back, it must be an even root. It can be x squared, x to the 4th, x to the 40th. But it must be even for it to bounce back. Some teachers call it bounce, some teachers call it touch. Some people write, like over here, they write a T above it. I don't like you to write a T above it because it looks like a plus sign. I'm just saying. So any way that you want to mark that that's a double root, if you want to list it, negative 10, negative 5, 0, comma, 0, comma, 5, comma, 5, that's fine too. I'm just too lazy. Okay, just need to make sure you have some way to note it. Okay, we knew that, we talked about yesterday about, green. All the parts that are going uphill are increasing. When we talk about slope, even though slope is a line word, we're going to use it very loosely to describe our equations. Slope is a steady rate of change. We're just talking about, does that thing go up or down? So that's increasing everywhere it's green. Here, where it's going downhill, it is decreasing. There's lots of information that you already know. And like I said yesterday, the one piece of information that I've given you that, well, obviously the balance and touch was too, but something that's a pre-calc concept because it's leading into calculus, is what you need to understand is that you can't go from decreasing to increasing, or increasing to decreasing, without, at that point where it changes direction, the slope equals 0. Without it going through 0, that slope. That is just incredibly important. That changes the whole attitude of the function.
Every change of direction?
Yes. There's a little blue arrow there, a blue arrow, yes. Every change of direction. And it doesn't matter if it's at 100 or negative 1 million. If it changes from positive to negative or negative to positive, you've gone through 0 slope. Any questions so far? We're good so far, right? Okay, like this bounce and touch thing, when I hit upon something that, even if it's one person doesn't know, it may be the whole class, you can get to it in Algebra 2, whatever. I need somebody to jump up and down and tell me, we don't know what you're talking about, or I don't know what you're talking about. I need somebody to tell me, because I'm assuming, and assuming is wrong, that you had all this online in Algebra 2, and believe me, I'm the worst learner online with math. I have to touch and feel it, I have to be face to face. So, even if you had it online, and it was presented to you, but you just didn't get it deep in your head, let me know. That's what I'm for. Okay. Okay, so we looked at our graph, we said it's x to the 6, we talked about 4 distinct roots, 6 roots total. We know there's increasing and decreasing functions. Now this particular, increasing, decreasing parts, this particular graph is not in our quadrant 4, but no big deal, it's all the other quadrants, so that's good. Okay, the first question says, is f increasing on the interval? Now interval notation, only, oh, you know what, come back up here where you wrote the interval stuff. Only x values. We don't look at y for interval notation. Ever. When you use interval notation, brackets or parentheses, you are always talking about the x values. Okay, so this says, is f increasing on the interval from -8 to -2? So that's an x to an x, right? So I'm going to use my fingers. -8 is here. -2 is here on the x-axis. So the piece I'm looking at of this function is between my two fingers. Is it increasing?
Yes.
Part of it is. Is some of it decreasing? So that negates the whole thing. So you have to say no. You can't say, well, some of it. It either is or it isn't. Okay, it's all or nothing. On the next one, is it decreasing from -8 to -4? So I'm going to use my fingers again. -8 is right there. Oh, I lied. Somebody catch me, I was ahead. Nobody caught it.
I was confused.
You were confused, you should say, Ms. Hoskins, I don't understand what you did. I screwed up. Hold on. It means the x values. It means exactly the x values. So I was ahead of myself. Okay. Is it increasing from -8? Here's where my finger should have been, right? This is -8 on the x-axis. Here is -2. Between my fingers, is it all green? Yes. Chalk that one up to me. That one's my bad. Okay. Is it decreasing from -8 to -4? So I'm going to put my fingers on the graph. -8 is here. -4 is here on the x-axis. Well, my graph is green. Green means go, and green means up to me. Is that decreasing? No. So that's no. It doesn't mean the point -8, -4. It means x to x. Is it increasing between 2 and 10? So 2 on the x-axis, here's 2, here's 10. Well, part of it is, but part of it isn't. Again, that's that all or nothing, so this is no. Is it decreasing from 2 to 5?
Yes.
Okay, from 2 to 5, that chunk is all going downhill. Do we know the slope? No, we don't. And we don't care. I do know that it's decreasing, and that's what I need to know. Okay, list the intervals on which f is increasing. So since I drew the colors on it, it really helps my eyes see the graph better. I'm very touchy-feely on math. I need to see it and not think harder. So I'm going to put all the intervals that are green. It's going to start at -8. It's increasing to -2. And I'm going to put parentheses around it. I'm not going to include either endpoint. I could, but I know the endpoints, it goes to 0, and that's not increasing. There's a little u that's supposed to be in here that I'm going to forget half the time when you do interval notation. I just don't like it. It's stupid, but anyway. Okay, my next x value is going to be from 0 all the way to this x value, which is 2. And then my last green segment is from 5, and it's not to infinity because I have I don't have an arrow on the end, 5 to 10.
Why are those not broken?
Because the actual point right there, the slope is actually 0, and that's not increasing nor decreasing.
Oh.
Okay? Now, if you put brackets on it, and I will tell you, I've seen SAT questions that include the endpoint because they're saying, oh, well, that's part of it. Yeah, that's sort of correct, but I'm trying to get you ready for calculus, and in calculus, that will be a 0 there. That's a 0 slope. It is not included. Just saying.
What is the U for?
This and this and this. The unit, it means united with this and this and this. It means and. I think it's stupid. I think if you put and sign, but anyway. When you do diagrams, Venn diagrams, like way back with circles that, okay, there's an intersect and a union sign. Union means everything. So that's what the U stands for. The intersect is an upside down U, and it means only where they cross. Anyway, I don't care to put the U there. I really don't. I think it's, I don't like it, but you know, trying to teach it the right way, not just my way. Alright?
Where's the highway?
My way or the highway. List the intervals that f is decreasing. Well, that's pretty easy because I've got it in red. Again, I'm using the x values. -10 to -8. And then I do -2 to 0. And then I do 2 to 5. Now, by exclusion, they cannot be the same thing. That interval, whatever interval you wrote on question 6, cannot be on interval 5. They are mutually exclusive. Okay, but they should, except for the points where it goes to 0, it should pretty much fill up your whole graph. Unless you had a horizontal line, a constant function, then that would be out of it. That would be 0. Okay, now here's where I'm going to need you to really listen to this and get this. Is there a local maximum at 2? So this is the x value. So I go to where x equals 2. Is this the highest point on my graph?
Yes.
Okay, yes. Now when I say local maximum, that means the snapshot I'm given. Even if this had arrows going up and down, the local max would be what is the picture in front of you. If yes, and it is, what is the local max, okay? So I want to know what is the value. The local max is at 2. This is the where question. What is the y value? So I go to where x equals 2, the y value is 10. So the local maximum is at 2, but the value is 10. Okay? Where is it is x. What is it is y. Big difference in those two words. Is there a local maximum at 5? Well, if 5 had been up here, then I would say yes, because it would match it, right? It'd be the same thing, but it's not. Nope. Okay, number 9, kind of repeating it, but it's just to make sure you get it. List the numbers at which f has a local max. The numbers at which. Where is it? Where is it? The local max is x equals 2. What is the local max? Y equals 10. Yes?
What if you have 2 local maximums?
Then there would be 2, and you would list 2
Oh.
points and 2 values, yes. And you could have 5, you could have 10.
They're
Now.
all the same height?
What?
They would just all be the same height?
Yes. Now, if this had arrows on it, if I had just drawn a little arrow here and an arrow here, this would still be the local min and local max. It's the picture. It's the snapshot in front of you. Even though I know that the right end might be going up to infinity, I'm not going to include it because I'm looking for just a snapshot of it. Maybe this is a graph of your business for 20 years, 10 years in the past and 10 years in the future or something. And they don't want to go 100 years in the future because you're not going to be alive or whatever, you know? I don't know. So local max and local min. List the numbers at which f has a local min. So where is the lowest spot? Right here. So the number where it is x equals -8. What it is y equals -4. So you need to remember local max and local min. And you can write it on the side of your paper or at the bottom, local max and min. Where is it? Is the x. What is the value? How much is it? Whatever is the y value. There's just a lot of information on here. Now, do you think that there is any one equation that can draw that graph? Not me. Not me at all. The right-hand part looks like a line. The slope changes from positive to negative, like parabola on the first 2 parts. And then it gets steeper, and then it gets really steep. I mean, so I don't believe that this would be one equation. I believe this would be a piecewise function. Just saying. Questions on anything you wrote here? Now, I want you to think a moment before you go. I'm going to hand you another paper, but hold on. If anyone, now that you're getting used to writing on your green sheet, we wrote that 0 slope and the no slope little rule if you wanted to, which I think is wonderful. The root solution 0 is x-intercept. You should have that on your green sheet. I need you to go back and think for a moment. If you have any trouble, and just watch for a second because I'll let you write it while I'm passing out papers. If you have any trouble with remembering m plus m equals 2m, m times m gives you m squared. You add those exponents. M to the fourth times m to the third gives you m to the seventh. But m to the fourth raised to the third power gives you m to the 12th. If that stumbles you at all, if you have to kind of think hard or just even think at all, you need to write an example like that down somewhere on your green sheet, because that's baby stuff, and I don't want you to screw up because you missed something from Algebra 1. If you want to write that down, be my guest. If not, that's fine too. It doesn't matter. I'm just saying, I'm just trying to catch all the places that you can screw up at before you screw up. Again, if you fill up your green sheet in the first month of school, I'll give you another. You can transfer what you need to keep on it. It is a dynamic document. It is not static. It's not meant to be not used. We do have a quiz tomorrow on composition functions. I don't expect it to be carefully taught. And with every quiz, I think with every quiz, most every quiz anyway, we'll have questions and answers before the quiz. You can ask questions, you can look back over your worksheets, and I'll say, ooh, make sure you know this. So it's not going to be come in, sit down, take a quiz. I will answer questions. Staples stick to each other. Okay, we're going to do a lot of these problems, and some of them we're going to skip because some of them are done. Some of them are super, like we can get 100 things off of it. Okay. Again, before we start number 1, what do you think this is a graph of? What equation? Say it again. Quadratic. I see 2 roots. I don't see any arrows, so it is finite. I see 2 distinct roots. Okay. So I'm thinking it's a quadratic. But the question says, use the graph below, use this graph, to estimate f of 0. Now this is using that graph stuff. I'm going to go to where x equals 0. Oh, and I do need you to notice, there is a difference in measurement or units on the x-axis and the y. The x-axis is crazy. It has letters, and it has some numbers, but letters, and then the y-axis is by tens. Okay. So if I go to f of 0, that's on the y-axis, what value is that right there?
24.
Sure. Anybody disagree? 23, 24, 25, 25.5, anything like that. I told you graphs are kind of inaccurate, and they're not inaccurate, they're just not real exact. So I would have to take basically anything from 20 to 30 on that one. Even though 24, 23 looks like a better guess. F of 1, I go to where x equals 1. What is that on the y-axis? About 10. I couldn't argue if you said 10 and 11. And here's where it gets kind of fun. F of b. Okay, I'm just giving you an x value. I don't know what that is. I don't know what b is. So I'm going to find b on the x-axis. There it is. Right there. Okay, so what's the y value? Oh, perfect. I like that. 8. Okay, I went to where x equals b. I'm sorry, it is -8. I was so excited you got it right. I was so excited. Usually that kind of messes things up. Okay, for f of c, I go to where x equals c. What is the y value there? It's 0, because that's a root, isn't it? So I'm going to write 0, but I'm going to write yay, because we found a root. I don't know what it is, but it's c. I know it's used once. F of d, I go to where x equals d. 21, 22, 20 something? 20. Just kind of depends on if you lean your paper and draw across the wrong way. I don't have graph paper on there, so it's kind of like, you gotta eyeball it. I'm all you can make lots of mistakes. So we could tell, like D, f of D, is up here somewhere around 20. I know that there's a 5 here, so this has to be bigger than 5, maybe 6, 7, 8, I don't know, because it's not really enumerated. But I know that sometimes in more than 5 weeks or whatever, my sales will be at 20-ish, whatever. I can guess a lot of I can garner a lot of information from that. Okay, the next part you're not going to like at all. It's all letters. Oh my gosh. You love it. Freak. Okay, before we get started, what kind of function is this?
Cubic.
Awesome! Cubic. It has only one root that I see. So that root is a triple root. Whatever h is going to be used 3 times. I know that it's going to be x minus h cubed, and there's some other stuff going on, but it's going to be at least that. It is finite. It has nothing but letters. Yikes. Now be careful when you answer this, because it's not always going to be as easy as it looks. What are the coordinates of the points P and Q? Here's P. Awesome! I go over B units and up A. So P is at BA. That is very good. I don't know what BA is. B could be 1 or a million. A could be, but it's positive. And here's the catcher. What are the coordinates of Q?
Negative D, negative.
Nope.
Just D.
Just D. Just E. Because D is already negative, isn't it? Oh, so Q is just DE. Because they're already negative. They are in the negative part of the x-axis and negative part of the y. So you got to be careful. Evaluate. So give me an answer for f of b. I go to where b is on the x-axis. What's the y coordinate there? The name of the point is p, but the y coordinate is a.
That's what I said.
So f of x equals e for x. So now I'm giving you the y value. Okay, I go to the y value. Where is there an e? Right here. What's the x coordinate right there?
0.
0. It is on the y-axis. It is 0. Good for you. Think backwards. Skip the next 2. We're not going to do it. D and E. Okay. Now this is, did y'all have physics last year, or do you have physics this year?
This year.
This year, okay. You're going to talk about velocity and displacement and things like that a whole lot this year, and this is getting into it. When we talk about distance, that is a fixed number, speed can change, and velocity is mass in motion. Anyway, okay. You have 2 equations. S of t equals 11t squared plus t plus 100. Be the position in miles. Underline that, highlight that. That's important. Of a car driving on a straight road in a straight road. Now, you know, this is fictitious, right? There are no straight roads. We have potholes. We have Buc-ee's to stop at, things like that. So, okay, in hours. The car's velocity. What's another word for velocity? Speed. Is given by this equation. Okay, so velocity is another name for speed. Now, if you think about it, this is a line. It's an upward line. It's going faster. So what does that mean as I'm driving? I'm going faster every hour, aren't I? I mean, so at 10 hours, I'm going 221 miles. I don't think so. But this is just a mathematical model, okay? You have to get used to what's real and what's not. We use mathematical models to give you an idea, but when we're doing real life, this would be stupid. Okay. Use function notation to express your car's position. Position, that's that first equation, after 2 hours. Where is, okay, I'm not gonna worry about where, I'm gonna figure out the position. So for A, I'm gonna use this first function. 11 times 2 squared plus 2 plus 100. I plugged a 2 in for my t. I don't like using t's because I'm too messy. So now you need to do your order of operations if you're doing it by hand, if you're doing it with your calculator knows the order of operations. It would do 2 squared and get a 4. 4 times 11 is 44, and then just add 44 plus 2 plus 100 is 146. What does that mean? 146 what?
Miles.
Miles, okay.
So that's where it is too.
That's where it is.
Like you've moved that far?
Well, okay, hold on. You've got the next question already. In 2 hours, I drove 146 miles.
That is pretty fast.
But it's not. My velocity, if I put a 2 in there, I'm driving 44 plus 1, 45 miles an hour the first hour. How did I go this far? Oh, hold on. What do we say about this 100? That's your starting spot. I started 100 miles from home. Oh, remember I told you that free information? You want to grab it. So this one means you started your journey 100 miles from home. That's why after 2 hours, you're 146 miles away from home. Because you started 100 miles away.
That's 46.
That's what?
46 miles to,
Well, because you're putting.
no. That's pretty slow.
Because the first hour he would have only gone, you know, you gotta think about it, okay. Alright, the second question says, use function notation to express the equation. When is it going 65 miles per hour? Now, 65 miles per hour is speed, right? What's the other word for speed? Okay, so I'm gonna plug this 65 into this equation. So I'm gonna say, when is it, I'm looking for a time. I'm gonna say time equals, no, I'm sorry, I'm gonna say 65 equals, because that's the speed, 22t, and I'm sorry if my t's get confusing, plus 1. My t's look like plus signs. Subtract 1, I get 64 equals 22t, divided by 22. Do not leave it as 64 over 22, I will mark it wrong. Okay, you divide it, and what do you get? If I divide by 2, 32 over 11. Now, do you talk like that? 32 over 11 hours? So if you have your calculator out, grab it real quick. I'm going to show you a really cool function on your calculator. Grab mine. And this doesn't matter if you have an old or new one. This is a great function. Plug this thing in all year. Come on.
What is that?
I know it. It's a dinosaur.
Don't worry.
I know they're low. You live with it. Okay. I want to show you something that you might not know, have known that was on your calculator, but oh my gosh, it's so cool. I want you to tell me, how long is 32 over 11 hours? Now, have you done kinesthetics, stoichiometry, where you do the fences? 1 foot equals 12 inches, and 3 feet equals 1 yard, and you cross out the units. Have you done that? No? You will. Okay, I need to convert 32 over 11 to normal people talk. I'm going to say how many hours and minutes. Okay, clear your screen. I want you to find on the apps button the word angle. See, it says angle there? Okay, let's look at it real quick. Hit second angle and look at the choices you're given. It says degrees, minutes, and then radians, and don't worry about that. We're gonna get to radians. That's what the whole unit circle is. But look at the fourth thing. It says degrees, minutes, and seconds. That little arrow says, would you like me to change it to degrees, minutes, and seconds? Okay, now there's 60 minutes in a degree. What other unit that we deal with has 60 minutes?
An hour.
An hour. So I can kind of just see hours, minutes, and seconds in my brain. Okay, so I'm going to clear that. I'm going to do 32 divided by 11. I'm going to go back to second angle and down to that DMS button. And I'm going to say, yes, calculator, please change it for me. Oh, 2 hours and 54 minutes. That's the answer you're going to want. I don't care if you give me the seconds. Isn't that a cool button to change a weird amount of time? If 32 over 11 is correct, but it's weird. So really the answer that would get you the most love from me is 2 hours and 54 minutes. That's the one that's gonna make you look smart, as opposed to dumb. Or opposed to dorky, you know. I'll meet you at McDonald's at 32 over 11 hours. Whatever, you know. Even I don't talk that way, and I'm pretty much, you know, between the doors. Okay. The last question, C. So that DMS button, you need to remember it's on your angle button, and it's on every calculator, no matter how old it is. It is very, very handy, and if you ever have to convert an ACT test, you don't have to divide by 60 or 3,600 to convert time. I think that's just a waste of time. Okay. Where is the car when it is going 67 miles per hour? Okay, so where is the position, right? But I don't know when, right? I have two things I don't know. So what I have to do is figure out at what time this is. So I'm going to say 67 equals what?
11t squared.
11t
Okay. Okay, so when it is going, 67 is the speed, right? So I need to plug it into this one. 22t plus 1. I subtract 1, I get 66 equals 22t. And when I divide by 22, this is really nice, thank you very much, t is 3. But that's not the answer.
I plugged 3 into that.
The question said, where is it? So I plug it into the first equation. So the answer, this isn't it, but this is getting me there. I need to put it into 11 times 3 squared plus 3 plus 100. Again, you have to do the order of operations first. This is a 9. 99 plus 3 plus 100. 202 miles away. So even though I gave you some information, and I was not looking for that, you had to use the other formula to get what you needed to give me the answer. Okay. The biggest deal with this stuff is you need to know what formula to put it in. Because I guarantee you, and I'm not kidding you, if you had plugged the 67 into the wrong equation, that answer is choice A or B or C or D. It's there. They're expecting you to do that. So even though you find the right answer on the SAT, don't jump on it. Double check yourself and just calmly walk yourself through it. I'm going to tell you that 95% of the time, your first guess is usually right. When you go back and erase it and change it, usually you're messing it up. Usually you have pretty good, especially you guys, you're so smart. Usually you have pretty good instincts. Okay, look back at this paper real quickly before I let you pack it up. We're going to finish it, probably not tomorrow. Tomorrow we're going to quiz, we'll see. Any questions on the back of yesterday's or today's? If you have not written on your green sheet and there is something you want to write on it, do it before you pack up, please, because it will escape your brain. Okay, you're done.
Is something like number 3 today on the quiz?
No. The quiz is composition of functions. I don't have any of this stuff.
So like with the table.
Table and FX and GFX. And I'm not even sure if I couldn't get the graph part to report on the online stuff, so I may take that off. That's something when I get all computer testers, I know.
So it's just going to be like algebraic
Yes, algebraic and tables. And I'll answer questions when you come in tomorrow. I'll say, okay, look at your worksheet, make sure you know this and this. We'll review it for the hours.
May I use the restroom?
Yes.